Okay, hello everyone, welcome back. We are going to start working towards the definition for the enthalpy of formation. And so we're really going to in this video, get some definitions and some work on different types of enthalpy. So let's get started. Okay, so it turns out that there are lots of types of delta H, and we represent these by subscripts. All delta H reactions can be found, and we're going to talk through this more in a couple of next videos, but can be defined as the sum of the enthalpy of the products minus the sum of the enthalpy of the reactants. But it turns out that there are some processes that are not chemical reactions, but also have enthalpies and heats involved. And many of these are phase changes. And so vaporization is going from the vaporization is not going from the gas. It is going from the liquid state to the gaseous state. And so we can calculate the energy required for this process, and that is known as the enthalpy of vaporization. Fusion is the chemistry word for freezing, and so that is going from a liquid to a solid. And sublimation is the process of going from a solid straight to a gas. And all of these phase change processes have energy associated with them, and we can calculate those if we happen to be able to find the enthalpy of each of the individual reactants and products. There's also what's known as bond enthalpy, and that is the energy that is required to break all of the bonds of the molecule. And there's also energy of formation, and that's the energy required to create a compound, a molecule, from atoms in their standard states. And so that's forming something. And so we would think about forming water from hydrogen gas and oxygen gas. Okay, so we're going to start using these over the next several videos. And what I want to start with is this enthalpy of formation. Okay, so we need some definitions going on here. A key one is standard state. A standard state is the most stable form of the substance that exists at room temperature 25 degrees C and atmospheric pressure 1 atm. So examples are carbon, and its standard state is a solid, and it's graphite, what your pencil lead is. Hydrogen is diatomic and it's gaseous. Lead is atomic and it's solid. So knowing what the standard state of the atom is at room temperature, room pressure, takes some work, but the best way to figure this out is by looking at a table of delta H of formation values, and the delta H of formation of something in its standard state is equal to 0. And so if you see a value in the table that is 0, you know that that is the standard state, so 0 joules. So the standard enthalpy change, delta H naught, it's got this little 0, is the change in enthalpy for a process when all reactants and products are in their standard state. And so this is not always, sometimes you're working with a molecule that isn't atoms, but we're still talking 25 degrees C and 1 atmosphere of pressure. Okay. And so we're looking at a process, and so we can think about, let's think about water splitting into its H2, its splitting of water. And so there's 2 of these and 2 of these. And so the standard delta H, there is a standard enthalpy value for this reaction. And that's when we have standard, it means that we are at 25 degrees Celsius and 1 atmosphere. And so the standard enthalpy of formation is the change in enthalpy when 1 mole of the compound is formed from elements in their standard states. And this is also at 25 degrees Celsius and 1 atmosphere of pressure. So examples are forming carbon dioxide from graphite and oxygen gas, or forming water from H2 gas and O2 gas. Now, notice that my stoichiometric ratio here has to be a 1. And so back in chapter, 2 or 3 last semester, we would have balanced this reaction as 2H2 plus O2 gas goes to form 2H2O. But the standard enthalpy of formation is only for 1 mole of water. And so we can't use this balancing. Instead, we have to use this half. And so when we are working with thermochemistry, the reactions are often balanced with fractions because we have to create 1 mole of compound from elements in their standard state. And by definition, the enthalpy of formation of a pure element in its standard state is 0. So the delta H of formation of this standard of this carbon graphite is 0 joules. Also for this O2 is also equal to 0 joules. Okay, so in the next video we're going to start using these relationships and seeing how they all play together. Keep up the hard work. I will see you in the next video.